So I'm going to do each of these problems the classical method first. You can fast forward if you prefer to use the other methods. I will show the other methods. 6 minutes. First, I'm going to identify what I'm given and what I want to find. I want to find a volume of NH3, and I am given 25 grams of N2. So I'm going to be given 25 grams of N2. I am going to need to find liters of NH3. So my layout for this problem is I'm starting with grams of N2, and I need to get to a different material. My only way to get to a different material is to be in moles. Once I get to moles, I can then use the mole-to-mole ratio and the coefficients from the balanced equation to get to moles of NH3. And then finally, I'm going to need to get to liters of NH3. 1 mole of NH3 is going to have 22.4 liters. So I'm going to need this relationship here in order to do that step. I'm going to need the molar mass of nitrogen, which is 28.02 grams in 1 mole. I'm going to need that relationship to do that step. And then the mole-to-mole ratio, I am going to need to look at the coefficients of each material in the balanced equation. I can see that it is a 2-to-2 relationship. Oh wait, sorry, no, this is a 1-to-2 relationship. So that's what I'm going to use for this middle step right here. So I'm going to lay it out, pause it if you'd like, and then check your answer to see if you got the same thing as me. So I've got everything laid out, each of my steps. I'm going to convert grams of N2 to moles of N2. Then I'm going to use the coefficients from my balanced reaction to find my moles of NH3. Then I'm going to use the relationship that 1 mole of NH3 is 22.4 liters, and that's going to get my liters of NH3. If you calculated this correctly, then you should get right around 39.97 liters or around 40 liters of NH3. All right, for the next problem, we're given grams of KClO3, and we need to find a volume of oxygen. So I've laid out my steps. I'm going to have to convert grams of KClO3 to moles of KClO3. Then I can use my mole-to-mole ratio to find out how many moles of oxygen, and then I'm going to convert moles of oxygen to liters of oxygen. So I've got my first step set up. I need to calculate the molar mass of KClO3. So I've got my molar mass of KClO3. I calculate and find how many moles of KClO3. Then I use my coefficients from the balanced equation. I don't want KClO3, so 2 goes on the bottom. I want to find out how much oxygen, so oxygen goes on the top. That's going to tell me how many moles of oxygen I have. Then my last step is going to be using the fact that 1 mole of oxygen is 22.4 liters in volume, and that's going to give me my answer. So you should get 1.37 liters of oxygen. So the next problem wants to know how many grams of KCl. So I'm just going to start with what I was given in the previous problem, convert to moles, so same step as what I did here. Use my mole-to-mole ratio to find out how much KCl, and then use the molar mass to find out how many grams of KCl. So you can see my setup here. I start with grams. I convert to moles using the molar mass of KClO3, find my moles of KClO3. It is a 2-to-2 ratio to get me to KCl, so I'm going to have the same number of moles of KCl as moles of KClO3. Then I use my molar mass of KCl to find out how many grams of KCl I'm going to be producing. So I should get 3.04 grams of KCl. So I've got the next problem all set up. I'm given 2.5 grams of zinc. I need to find out how many liters of hydrogen. So my steps are going to be to convert grams of zinc to moles of zinc. Then I'm going to use the mole-to-mole ratio to find out how many moles of hydrogen. Then I'm going to go ahead and convert that to liters using 1 mole is equal to 22.4 liters. So you can see my work here for each of those steps. First, converting grams to moles of zinc using the molar mass, then using the mole-to-mole ratio from the coefficients of the balanced equation to find my moles of hydrogen, then using 1 mole is equal to 22.4 liters to find my liters of hydrogen, and you should get 0.86 liters of hydrogen. So you can see for the first problem, I laid out what I start with, grams of sodium sulfate, Na2SO4. I need to find out how many molecules of water. So my first step is going to be to find out how many moles of sodium sulfate I have, then use my mole to mole ratio from the coefficients of the balanced equation for each material. Then I can use the relationship that 1 mole is equal to 6.02 times 10 to the 23rd molecules for my final step. So you can see my setup here for each step, converting grams to moles, using my mole to mole ratio to find my moles of water, using my 1 mole is equal to 6.02 times 10 to the 23rd molecules to find my molecules. And you should get an answer of 8.47 times 10 to the 21st molecules of water. So I went ahead and read the next problem. I'm given 10 grams of aluminum chloride, and I need to find out how many molecules of a different material. So again, I'm starting with grams of a material. I'm going to need to find out how many moles that is. I'm going to use my mole to mole ratio from the coefficients of the balanced equation to get from moles of aluminum chloride to moles of chlorine. Then I'm going to use the fact that 1 mole of chlorine is equal to 6.02 times 10 to the 23rd molecules to find out how many molecules of chlorine I have. So you can see I'm all set up. I first convert grams to moles by using the molar mass. Then I use my coefficients from the balanced equation to go from aluminum chloride to chlorine, and I find my moles of chlorine. Then I use the relationship 1 mole is equal to 6.02 times 10 to the 23rd, and so that gets me an answer of 6.79 times 10 to the 22nd molecules of Cl2. So for these problems, I'm going to do the same problems, but I'm going to use the other method to solve them. So I'm still going to identify what I'm given. I'm given 25 grams of nitrogen, and I want to find how many liters of NH3. So what I'm actually going to do is I'm going to figure out, well, how many liters of NH3 does the reaction tell me? Well, since the reaction tells me 2 moles of NH3, and 1 mole of NH3 equals 22.4 liters. That means that 2 moles is 44.8 liters. So this is my liters of NH3. I'm also going to look at my nitrogen. The balanced equation says 1 mole of nitrogen. So I want to find out how many grams that would be. Well, 1 mole of nitrogen is going to be 28.02 grams. So these are the 2 pieces of information I need from my balanced equation to solve the problem. So I start with my 25 grams of nitrogen. Since I don't want nitrogen anymore, it's going to go on the bottom. Well, my balanced equation says 28.02 grams of nitrogen. I want to find my liters of NH3. The balanced equation says 2 moles, which would be 44.8 liters. So that's one way to solve it. I can also do the cross multiply method. Again, same pieces of information I'm going to need. 25 grams of nitrogen over my unknown liters of NH3. I'm going to set that equal to what the balanced equation tells me. The balanced equation says 28.02 grams of N2. And the balanced equation says 44.8 liters of NH3, and then I just cross multiply to solve. No matter which way you do this, you're still going to get the same answer. You should get 39.97 liters of NH3 as your answer. All right, so on the next problem, I'm given grams of KClO3. So that means I need to know from the balanced equation. Balanced equation says 2 moles of KClO3. So I'm going to need to know how many grams that is because that's what I'm given. So I find the molar mass of KClO3 is 122.55 grams. So I would need to multiply that by 2 to find out how much 2 moles of KClO3 would weigh. So according to the balanced equation, 245.1 grams of KClO3. So I'm going to be using that. The other piece of information is what I want to find. I want to find my volume of oxygen. So the balanced equation says 3 moles of oxygen. Well, I need to know how many liters that would be. So 1 mole is 22.4 liters. So I'm going to multiply that by 3. And the balanced equation then tells me that there are 67.2 liters of oxygen. So this is the other piece of information I'm going to use from that balanced equation. So again, if I solve this the alternative way, I start with my 5 grams of KClO3. I don't want grams of KClO3, so it's going on the bottom. My balanced equation says 245.1 grams of KClO3. And then I want to find liters of oxygen. My balanced equation says 3 moles. 3 moles would be 67.2 liters. And then again, if I did this in the method where I cross multiply, here's what my work would look like. So here's my cross multiply and solve for x. No matter which way you solve it, you should still get the same answer of 1.37 liters of oxygen for number 2. So here's the setup for the next problem. I'm starting with grams of KClO3. Again, the balanced equation tells me 245 grams because 2 moles would weigh 245 grams. I need to find out how many grams of KCl. So I'm going to look up here. I'm going to find the molar mass of KCl. The molar mass is 74.5, but I've got 2 moles. So that's how I got 149.1 here. Here in blue is the cross multiply method. No matter which way you solve it, your answer for number 3 should be 3.04 grams of KCl. All right, so the next problem, I'm given 2.5 grams of zinc. I need to find out how many grams of zinc the balanced equation says. I see no coefficient in front of here, so that's going to be 1 mole of zinc. So all I need to do is look on the periodic table, find the molar mass of zinc, 65.39, and that's going to be my grams of zinc, because again, the balanced equation says just 1 mole. 1 mole weighs 65.39. Now, if I look at hydrogen, hydrogen also does not have a coefficient in front of it. 1 mole of any material is 22.4 liters. So since I just have 1 mole of it, that is how many liters of hydrogen. I solve for my x, and my answer for problem number 4 should be 0.86 liters of H2. All right, next problem, I'm given 2 grams. According to the balanced reaction, I have just 1 mole of Na2SO4, so 1 mole would be 142.04 grams. I want to find out how many molecules of water. Well, I also only have 1 mole of water, so 1 mole of water is 6.02 times 10 to the 23rd molecules. Cross multiply setup is over here in blue. No matter which way you do it, you should get an answer of 8.47 times 10 to the 21st molecules. All right, and the last problem, I'm given 10 grams of aluminum chloride. The balanced equation says 2 moles of aluminum chloride. Well, 1 mole weighs 133.34. Multiply that by 2, that means the balanced equation needs 266.68 grams of aluminum chloride. Aluminum chloride cancels out. I want to find out how many molecules. Well, the balanced equation says 3 moles of chlorine. So I'm going to have to do 3 times 6.02 times 10 to the 23rd, which is 1.81 molecules. So remember, this comes from the balanced equation. I have to calculate it, and I have to calculate it, and that will give me an answer of 6.79 times 10 to the 22nd molecules. And in blue down here, I do have the setup for the cross multiply method.